In this video, we'll cover nuclear reaction and we will be focusing on electron capture. Nuclear reaction occurs when there is an unstable nucleus within an atom. The unstable nucleus will try to achieve stability by going through a nuclear reaction. Here are all the series of nuclear reaction, but our focus again is going to be on electron capture. An example on the right here, it says ruthenium. It shows that ruthenium 92, and there is a capture of an electron-like particle. So that is referred to as E0 and -1 on the bottom. -1 because it's negatively charged. Now, this unstable nucleus, the ruthenium, is going to draw in this electron and converts a proton into a neutron. So if you look in this green is the proton, and this white portion is a neutron. So you can see the change from the proton to a neutron, meanwhile, while capturing an electron. This happens when there are too many protons and too little few neutrons in heavy elements. So these are the ones that are on more close bottom of the periodic table, maybe not mid bottom. And then so you see there's a few neutrons, so little of the numerator and a lot of the denominator. So N over Z, you might see this as being small, or I should say maybe less than 1 approximately. So this will be quote unquote small in value. In a lot of cases, you might see less than 1. So having too little neutron and proton, having a very small N to Z ratio, you might see this electron capture occurring because perhaps it needs more, it has too many protons, so it needs more neutrons. So the proton will then change to neutron. So let's go ahead and do a learning check based on what we have covered so far. Here's krypton 81. It's going to go through electron capture. If it goes through electron capture, so there's essentially catching electrons. So maybe this arrow was drawn a little too close. So I'm going to kind of erase that by putting this ink over it. I'm going to plus the electron capture. So that's my E, and then -1, 0. Okay. Now that forms into something, and we're going to figure out what that something is. What we need to know is that the mass number on the left-hand side and the mass number on the right-hand side should equal out. So as the proton number. And not just any proton number, but the summation of the mass number and summation of the proton number. For example, here's my mass number, and on the bottom is the proton number. The mass number is 81. So I write 81 plus, and the mass number for electron capture, this particle would be 0. So I have a totality of 81. That means in total, I should have 81 on the right side. And there should be just an element form, so that's one atom form, so that's 81. What about proton? We have 36 from the krypton, and then you're going to add the -1, that's from the electron capture. That would give me 35. That means on the right-hand side, it should totality will be 35. And since there's only one atom that will form, it will be 35. So what in the periodic table has the atomic number of 35? Come back and check this video again. Hopefully you were able to get bromine. Br has 35, so bromine 81, this particular isotope, is what is formed from krypton through electron capture. Now here it says silver 106. Show silver 106 going through electron capture. So let's go ahead and write that down. Silver 106, and silver in the periodic table would be 47. And then it's also going to capture electron. So figure out what might be on the right hand side and come back and check this video. So hopefully you were able to get palladium on the right hand side, 46 and then 106 as the mass.